All right, this is the video on how I built my four-way wedge. It is a slip-on. Originally, I had the cross piece welded onto this. This was rigid, and it was like that for decades. It just kept tearing. You know, once a year, I'd have to re-weld the whole thing on. And I mean, it came factory with something that was very similar to this, but only made out of 1/4-inch steel. This is made out of snowplow, 1/2-inch snowplow cutting edges, and welded to a heavy plate. And like I said, I had a cross piece on there, which is used on this. And this was very simple to do if you're going to do it. I have 1/4-inch plate. I cut two pieces that were about the same size as height as this and a little bit longer. I just took a clamp and I put some pieces of shoebox cardboard, real thin, you know, like the gray cardboard, here and here, and I clamped these two pieces to here, and I spot welded here and here and here, and then I took it off of there. I flipped it like this, and I ran as best beat I could with my tiny little Harbor Freight, what is it, titanium 140 flux core welder. I just laid as heavy a bead as I could in there and shut the fuse off a couple of times. I mean, it was hot in there. And then I was ready to move on. This piece here is a 1/2-inch cutting edge off of a dozer. This originally was on my single wedge. I cut it off. When I cut it off, it made it a little bigger, so it fit this well. When it was on originally, it was a piece of the dozer edge cut back on an angle, and then a dovetail was taken out of it to fit over that wedge. Now that dovetail fits over this wedge, and welded that on there. It was also cracked here, so as you can see, there's some significant plating here. This plating on the bottom is narrower than the angle of the wood coming off, so wood going through it doesn't get caught on it. And of course, this one is below these little pieces of angle. These pieces of angle were flipped upside down and put on here, so once the secondary cutter of the four-way got through it, it would push the upper piece up. And that is it. I got a friend of mine who knows how to weld, because I do not know how to weld. I tacked the whole thing together, and he laid these fatties in here, these giant, I mean, they're just giant, monstrous welds. We ground them down. We made sure everything was hunky-dory. We did it again. He put a bead up in the back there that's monstrous, and then he put a couple of beads down the front, which I took a big grinding wheel to and sharpened, because a sharp, especially for a four-wedge, sharp cutting edges make all the difference in the world. Especially you get into stuff like this here. I'm going to do a quick demonstration. I have these big chunks of dead ash that I'm trying to get rid of. Well, not trying to get rid of. I have a customer who ran low on firewood, and I'm trying to give him something that we can guarantee will burn to get him through the rest of the season, which is usually middle end of April. And now we're in the middle of March. Anyway, yeah, he laid on these beefy beads to hold this from splitting anymore. And at first I would have thought that this was too light steel for this, but it can't go anywhere. If you push on it, it wants to spread out, and this is not letting it go anywhere. This back piece is now 1.5 inches thick of steel, almost. What is that, 1.25 inches? That might even be 1.5 inches. And I mean, this thing is welded up. Unlike when it was on the stationary wedge, we got a really nice weld in here, and as you can see, it's welded down there. It is a little bit larger than that. Sometimes that wedge that it slides on, sometimes it will rattle, and it's a little, you know, you hear a strange rattle on your machines, and you're like, what's that? And you can see in there, I'm sure, where it's, you know, compressing on the weld and, yeah, stuff like that. But you're going to have wear on machinery. Now, we're going to take a look at how it sits. on the whole machine. All right. This table is 1 inch below this surface here. This surface is the plate, the 1/2 inch plate that's welded on top of the beam. The beam is a 1/2 inch above that plate. And the reason this is done like this is so when the 4-way wedge goes on, all right, well, the wood has to rise to cut this. As you see, this is the bottom. And we'll put it on. It slides right on. The wood rises to cut in there, but you have a place for the wood to go. The wood has to separate. Even though that's a flat edge, it'll have a tendency to pry away because you're between two pieces with something, and it'll push it down. And that gives it enough, even with a 24-inch piece of wood, to get all the way out of there without compressing and sticking in there. Of course, compressing and sticking it, when wood compresses and sticks in there, now you're fighting your next thing. And it's one of those things where it's not going to really hurt this piston, but it is going to reduce the usable life over time. How many times is your machine going to go back and forth? I mean, this thing, I've had this since 1993. Nah, 4. Yeah, about 1994, I've had this splitter, the basic splitter portion with this beam on it. So you'll get amazing life out of some of these machines if you pay attention to repetitive motion damage. Anyway, long and short of it, it's much better, I feel, to have the slip-on wedge. And the reason is when you get into really hard material, you'll actually sink up to here before it opens, and then you're cutting your splitting surface is not just this one. You have this 8 inches or 7 or 8 inches, whatever that is, and then you have this additional almost 10 inches, and on this machine you'll see this beam flexing. And if you can avoid that by using a single wedge, that's great. Back to something I touched on the overview of the machine in itself. I'm going to split a 22 or 24 inch, 20 inch maybe, I don't know, diameter log as a demonstration on this, as why my table is the shape it is. Again, there's those chines that are in there, strakes, whatever you want to call them. If they're a boat, they're chines, to guide the lower pieces of wood straight forward onto the conveyor. And the reason the table is so big is so that for bigger wood, once you split it, it does not have to be lifted again, because everybody who has ever split wood will tell you it sucks. You just have to keep picking up that same piece of wood over and over again. That's why you see guys with those just the addition of a simple table on their splitter, how happy people are. Just limit everything, and the idea is to limit as much as possible. Anyway, let me fire up the machine and get my hearing protection on, and we will slap a big log on this, and we'll show you why this is a good thing. Now, there is a misnomer for people that a 4 split will save you, you'll get three strokes out of it every time. Not always the case. You end up with stuff that has to be split again, like that's not going to split into 4, it's going to split into 2, or isn't the right shape to split into 3. And through the 4-way splitter, split into 4. So it's not perfect, but it does save an incredible amount of work. Hopefully this is going to be really hard, and you're going to get to see what I'm talking about with the first hand with the hardwood flexing the beam. Now, drawback. It's nothing we can't fix. Looks like we separated a little bit. Whatever. It's always see the downfalls of all this kind of equipment. Everybody thinks it's a complete bed of roses, and it's not. There's always something, right? Alright, back on to splitting with the 4-way. And it does save a lot of effort. It really does. Doesn't even want to stay in there.